So our T number is number 16 and we were assigned to with a thermal actuator sensor. So speaking of thermal actuator is an actuator that creates motion or kinetic energy using the heat expansion amplification. So in this project we were able to implement the layout for our actuator design. We were able to derive the layout for our project. We were also able to choose our materials and we thus deriving the solution for the design using the NC software. But in order to derive the solution for NC software, we need to implement the 3D model first in the MEMS Pro. So the below figure shows the basic design that we use for our project, and the choice of material database we have used for our project is titanium, aluminum, SU8 glass, deformable layer, and sacrificial layer. And after choosing the material database, we have to do the process definition for the design and thus creating the 3D model for our design using the MEMS Pro. So this is the layout for our MEMS thermal actuator design, and these are the layers that we have used for our design. And this we actually use aluminum, titanium, SU8, and deformable layer and sacrificial layer as our materials for our MEMS thermal actuator design. Thank you.
Assalamualaikum, my name is Luqman Hakim Zaidi and I will talk about MEMS fabrication simulation. Firstly, on the material, we use seed material which is glass, titanium, aluminium, SU8, sacrificial layer, deformable layer. There are 13 process step. So firstly is we substrate the wafer. So the wafer we use the glass, and secondly the process is deposit titanium. Third is deposit aluminium, deposit SU8, SU8, etching aluminium, etching titanium, etching aluminium, deposit sacrificial layer, etching sacrificial layer, deposit deformable layer, etching deformable layer, and lastly we etch sacrificial layer. So as you can see at the bottom the slide, we have final 3D model and the final cross-section.
Assalamualaikum and hi, my name is Muhammad Nur Anik. Okay, and I will present about the MEMS finite element analysis. Okay, in this system we use two analysis system, which is steady state thermal and static structural. We use the same engineering data, geometry and model for the two system. Okay, as you can see here is our geometry from files MEMS Pro. Okay, this is the project after mesh. Then as shown in the input boundary condition and that we set in our project. For the convection, we set at deformable layer and at our titanium. Then the temperature we set at aluminium and at our SU8. Okay, then as you can see also, for the input at the pressure, we set at the surface of the deformable layer. As shown here is the result for NC's solution for the material that we use. In this project, we use 4 different material that we change at deformable layer, which is silicon, magnesium, gold and copper. The graph shown total deformation against input pressure. The input pressure we set as MPa, while the total deformation we set as micrometer. Thank you.
Assalamualaikum and good morning. My name is Muhammad Nur Adli bin Jamaluddin. I'm from group 16. So today I will talk about thermal actuator provides speed for soft robot. Soft robot. A researcher from North Carolina State University has developed a new thermal actuator that provides soft robot with boost in speed. Thermal actuation is common in soft robot, which create motion by turning energy into work, and while it's efficient for locomotion, it lacks speed. Work by implementation by a bistable design. Think of it like a snap hair clip, which is stable until pressure is introduced and snap it into a different shape. It's the bistable design that gives an actual increased speed. It's functional by layering two materials on top of each other with silver non-wire sandwich in the middle. Both materials have different coefficient of thermal expansion, meaning they expand at different rate when heated. In other words, the material bend when heat energy is introduced. So for the second part, is what MEMS thermal actuator for clean and renewable energy. Actuators are simply devices that transform energy into motion. A thermal actuator is a type of non-electric motor made of components such as piston and thermal-sensitive material capable of producing linear motion in response to temperature change. Thermal actuator doesn't require outside power source to produce motion. In thermal actuator system, temperature change can be used to perform predefined tasks such as release latch, operate switch, and open focus valve. Thermal-sensitive material used in thermal actuator respond to fluctuation in temperature causing the actuator piston component to move. That's all from me. Thank you. Okay, for the last part, this project we refer to these three papers. Number one is X1, number two ML2, number three SKO. This is an article that we refer. Thank you.